we're now at the point in the chapter where we can begin thinking about reactions that happen in aqueous solution. So reactions that happen in media where water is the solvent. And there's 4 types of reactions we're going to go over. There are precipitation reactions, there are acid-base reactions, there are gas-forming reactions, and there are oxidation-reduction reactions, also known as redox reactions. We'll cover all 4 of these in turn, but this time we're going to start off with precipitation reactions. And what happens in a precipitation reaction, I abbreviate reaction by writing the letters RXN. In a precipitation reaction, 2 compounds that are soluble in water, that dissolve in water, 2 soluble substances react to form an insoluble substance. And that insoluble substance is called a precipitate. Okay, so they react to form an insoluble substance called a precipitate. As you can probably imagine, your solubility rules are going to be pretty important in determining what's going to go on in a precipitation reaction. And what I have here are 2 compounds dissolved in water. This one happens to be, I hope you can see that, sodium hydrogen carbonate. It's a soluble substance. We know that from the presence of the sodium ion in the compound. If you got sodium ion in a compound, it's going to dissolve in water, which is what we see here. I also have some calcium chloride solution. Calcium chloride, CaCl2. Most chloride salts are soluble. Calcium does not happen to be an exception to that rule, and so clearly calcium chloride is going to be a soluble substance, and we can easily see that. I mean, the substance is dissolved. So I have 2 soluble substances. I have some sodium bicarbonate, and I have some calcium chloride, and we're going to mix these together. I guess I just need 1 flask. We'll mix these together. Well, let's pour them together. It's more fun that way. We'll pour this here. That's my sodium bicarbonate. Here's my calcium chloride. And now we'll mix them together. Here we go. Oh, look at that. Something happened. Looks kind of chunky in there, white and chunky. A solid was formed. An insoluble substance was formed in the reaction between dissolved sodium bicarbonate and dissolved calcium chloride. And you know what's interesting about that is we can use our solubility rules to figure out what this white stuff is that formed. At the start of this reaction, I know I had some sodium hydrogen carbonate that was dissolved. So I can write it like that. It reacted with some dissolved calcium chloride. Now what I'm going to do for this precipitation reaction, we formed a precipitate, that's the white stuff here. I'm going to break each of these compounds up into their individual ions. They dissociate. It's an ionic substance that dissolves. It's going to be a strong electrolyte. So I'll go ahead and write here, I have sodium aqueous plus hydrogen carbonate aqueous. That comes from this. And when this dissociates, I'm going to get a single calcium ion. And I'm also going to get 2, whoops, this should be a plus, not an arrow, plus 2 chloride ions. I hope you see that. When this dissociates, I'm going to get a single calcium ion, and I'm going to get 2 chloride ions. Now what we have to do is we have to think about what cation and anion paired, of course it's always going to be just cations and anions pairing up to make a compound. So what cations and anions paired up to make this white stuff? Well, I know it's not going to be sodium, because sodium, anything it attaches to, it dissolves. So I can eliminate that. That means there's probably going to be calcium in this. And I know it's not going to be calcium chloride, because I started out with dissolved calcium chloride. It's going to stay dissolved. So it's going to turn out that the calcium is going to react with the bicarbonate, and that's going to be the compound that was formed, calcium hydrogen carbonate. We can tell this from our solubility rules, and indeed most hydrogen carbonates are going to be insoluble. So what I want to do here is I want to say, okay, what would have formed? Well, it's going to be a calcium ion, and that's going to react with, it's going to need to react with two of these, because there's only a -1 charge here and a +2 here, so I have to form calcium hydrogen carbonate with two hydrogen carbonates. That's going to be a solid. Now, of course, if I have two bicarbonates or hydrogen carbonates, I better start with that many. And this is paired with sodium, so if I have two of these, I'm going to need two of these. And so what will happen here is my two sodiums will just go along for the ride, they'll stay dissolved, and my two chloride ions will stay dissolved as well, of course. And this is nice because you have to have charge balance, and of course I have two sodiums with a +1 charge and two chlorides with a -1 charge. Everything works out here. What I've just written here is what's called the complete ionic equation. Complete ionic equation for the reaction between sodium hydrogen carbonate and calcium chloride. And in the complete ionic equation, you write all of the ions that are involved in the process. That, I should say, that show up in the process. So we start out with two sodiums, two hydrogen carbonates, a single calcium, and two chlorides. And those react, actually it's just the calcium and this that react to form a solid that precipitates out that we see. And then your sodium ions and the chloride ions, they stay dissolved. And we're completely showing all the ions involved in the process. Sometimes we ignore the ions that aren't doing any reaction. In other words, they're showing up dissolved at the beginning and dissolved at the end. They're just hanging out there, kind of, so to speak. And we call these spectator ions because they're just sort of watching the process, I guess. So if we have something that's dissolved in dissolved form at the beginning and in identical dissolved form at the end, we can cancel them out. You got two sodiums going in, you got two sodiums going out, that's no net change. Where's your other spectator ion in this process? I hope you've identified the two chloride ions as the spectator ions that we can cancel out, because the two chloride ions stay dissolved as a result of the process. And after canceling out the spectator ions from the complete ionic equation, what we have left over is what we call the net ionic equation. So I'll draw that up here above. The net ionic equation for the reaction between sodium hydrogen carbonate and calcium chloride would look like this. Let's see, I'm going to need calcium ions, and I'm going to need two hydrogen carbonate ions, and those are going to react to form calcium hydrogen carbonate solid, my precipitate. So this would be called the net ionic equation. And you get the net ionic equation by first writing out the complete ionic equation and then canceling out the spectator ions as I've shown here.